आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello friends, welcome. The question states, everyone who passes the test will be awarded a degree. So anybody and everybody who can pass the test is going to get a degree. The probability that Tom passes the test is 0.5. So for Tom, probability is 0.5. So we'll keep the value in mind. And probability for John is 0.4. So for Tom is 0.5, John is 0.4. And the two events are independent of each other. So before we proceed in this particular question, let me write out these values because the question is very big. Now, I know that the probability of Tom passing is 0.5. Similarly, the probability of John to pass, right? For John to pass is 0.4. So Tom passing, so I'm gonna add P, and John passing P is 0.4. As in the question, it was given that probability that Tom passes the test is 0.5 and the probability that John passes the test is 0.4. So we attained both of these values. But the most important thing here is the two events are independent of each other. So what does this conclude, or what does this mean whenever it is said that the two events are independent? So whenever we have two independent events, or I can say that if A and B are independent events, right? So independent events, then I can say that probability of A, right? Probability of event A multiplied by probability of event B. So probability of event A into probability of event B is equals to nothing but probability of A intersection B, right? So probability of A into probability of B is P A intersection B. So what is A intersection B? If I draw the figure for this, right, and I have this region as region for A, this region as a region for B, right, and this is the entire set. This is the entire set. So this overlapping region is A intersection B, and this complete region including A intersection B, this region is known as, so this complete region is known as A union B, right? A union B. So what does A intersection B mean? Both A and B. So both, right? And A union B, what is A union B? At least one, right? So if we need to find both, A intersection B is our answer. If we need to find at least one, then A union B is an answer, because it is going to comprise of A, B, and B both. Now let us look at the question. So here we have two columns, column A and column B. Column states that A states that the probability that both Tom and John get the degree. So it is talking about both. So both is this region, right? Both is this region, A intersection B. And the column B states the probability that at least one of them gets the degree. That means at least one of them is going to get the degree. So for at least one, which region are we talking about? This entire region, or A union B. Here we just had PA intersection B, and this is both, right? So P intersection B is PA into PB. So I can quickly obtain the value of column A. So what is the value of column A? It is equals to P intersection B. P of A intersection B. So let me name this as column A. So column A is equals to PA intersection B is equals to probability of A into probability of B. So what are the events A and B here? Tom passing is 0.5. So I'm going to name this as event A. And John passing, I'm going to name this as event B, right? So Tom passing is 0.5, John passing is 0.4. So let us replace over here. So we get 0.5 into 0.4, and 0.5 into 0.4 is 0.2. So I definitely obtained that the value of column A is 0.2. So I have the value of column A, which is 0.2, fixed value. So A intersection B, according to this phenomena, is 0.2, right? Because in the question it was mentioned that A and B are independent events, or Tom passing and John passing are two independent events or independent of each other. Now, let us find out the value of column B. So, column B. Now, what is column B? A union B, right? A union B. Why? Because it is nothing but the probability that at least one of them gets the degree. So, at least one. And we just learned from the graph that at least one is nothing but A union B, the entire region. But how are we going to find the entire region? We don't know any formula or we don't know anything about it, right? So column B is nothing but probability of A union B, right? So how can we find that? So let me tell you a quick formula for unions, right? So if I talk about the formula for unions, I can actually say that probability of A union B, where A and B are any events, is equals to probability of A plus probability of B. So graphically also you can see A plus B minus A intersection B, because this overlapping area is counted twice. Once for A, once for B. So we need to subtract it once. Minus probability of A intersection B, right? And here column B is A union B. So this is nothing but column B. Now, we have the PA. So here we have considered A as Tom passing, which is 0.5. And John passing is 0.4. Minus PA intersection B. So we already found out the value of PA intersection B in column A. So column A was that value, which is 0.2. 0.5 plus 0.4 is 0.9. Minus 0.2 is 0.7. So this is 0.7. And 0.2 was the value of column A. So column B, so I'm going to call this as column B in a square box. So this is column B and column A in a square box. So column A is 0.2, column B is 0.7. Which one of them is larger? Absolutely 0.7 is larger. So 0.7 is larger than 0.2. So I can say that column B is larger than column A. So the answer is if column B is larger. So my correct answer is going to be option B, which is if column B is larger. So our answer for this particular question is going to be definitely option B, which is if column B is larger. Once again, if I'm going to overview, I can say the probability that both Tom and John get the degree. So Tom is event A, John is event B. That's what we called them. From the graph, both A and B is this overlapping region, which is called as A intersection B. So both of these intersection, and from the information given in the question, we realize that they are independent events. So by the formula of independent events, we know that A intersection B is equals to A into B, or the probability of A intersection B is probability of A into probability of B. So we found out the value of probability of A as 0.2. Now, the second part is the probability that at least one of them gets the degree. At least one of them gets the degree. So that means it's the entire region on the graph. So region A, which was for Tom passing, region B, which was for John passing, this, and also the region which involves both of them passing. So we need to find the entire value. And how did we find out that? Simply by using the formula for union. So column B was probability of A union B. So probability of A union B has a formula of probability of A plus probability of B minus probability of A intersection B. And we have assumed that Tom passing is event A, John passing is event B. So we simply substituted the values as 0.5, 0.4 and 0.2, which we obtained in the previous case, to find out the value that the probability of A union B, or at least one of them passing, is 0.7. And obviously 0.7 is larger than 0.2. So we can say that the column B is larger, which talked about the probability that at least one of them gets the degree. So our answer for this question is option B. That is it, guys. Thank you so much for watching.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।